What's up guys, it's me Sir Ernest, and today let's talk about conservative and non-conservative forces. So as you recall that for a particle undergoing displacement from point 1 to point 2 under the influence of a force, which is a function of x, or a function of position r, we know that the work done is equal to the change in kinetic energy, and if this force is a conservative force, this is also equal to negative delta U, which leads us to the statement of conservation of energy, wherein energy, which is the sum of your kinetic and potential energy at any given point in time, is a constant. Now, how do we know whether the force is conservative or not? Okay, so a force F is conservative only and only if there exists a continuous differential scalar field, let's say U or V, okay, which can be a function of x, y, z in Cartesian coordinate system, such that the force is just equal to the negative gradient of your scalar field. In our context here, this scalar field is your potential energy U. Now, another statement is that if a force is a continuously differentiable force field, is conservative if we take the closed integral for a simple closed loop or simple closed curve. The line integral, let's say from point 1 to point 2, let's say from this point going back to this point, the line integral along this closed loop, if this is equal to 0, that means this force is conservative. Now recall Stokes' theorem. Stokes' theorem states that the line integral along a closed path of a vector is just equal to the surface integral of the curl of that force along the surface that is defined by the closed loop. So, if F is conservative, Stokes' theorem also says that the curl of that force must also be equal to 0. Okay, so that's it. So either you get the line integral and then you equate it to 0 to check whether the force is conservative, or just take the curl of that force and check whether it is 0 to determine whether the force is conservative or not. And if the force is conservative, there exists a potential energy associated to that force, F. Okay, so in the next video, we're going to solve an example illustrating these concepts. Okay, so for now, thank you for watching. Thank you guys, and I hope you learned something today, and I'll see you guys in the next video. Bye.